Hey class, this is Mr. Roberts, Shasta High School. I'm sitting here with I guess I'll call this a mini preview of the test that we're taking on Friday. Kind of a review of things that we've talked about in this chapter. Here's a lovely problem. You might want to pause the video, try it yourself. I'm going to go ahead and proceed by multiplying both sides of this equation by the number 10. If I do that, it will clear the fractions. One of the things that's kind of tricky here is when you're looking at this, you've actually, whoops, don't forward. When you look at this, you've actually got several different terms on each side. So, for example, on the left-hand side, I've got this term right here, right? Because it's 3/5 times the quantity of 4x minus 5, and then I've got this term. On the right-hand side, I've got this term, and I've got this term. So when I multiply both sides of the equation by 10 to clear the fractions, I got to be really careful that I multiply all terms on both sides by that value 10. So I'm going to go ahead and put some parentheses around this, and I'm going to multiply both sides of this equation by 10. I know that if I have equal things, check, and I multiply by equal things, 10 on each side, I'll get equal things. On the left-hand side, I have 3/5 times the quantity. 3/5 times 10 is going to equal 6. So this is going to become 6 times the quantity of 4x minus 5. And then I'm going to have, let's see, 10 times negative 7/10. That's convenient. That'll completely get rid of this fraction. It'll just become a negative 7. On the other side, we're going to have 4/5 times 10, which is going to be 8x, because 4/5 times 10 is 8, and then minus 2 times 10, which is negative 20. Now I'm going to go ahead and distribute on the left-hand side. 6 times 4 is 24x, minus 6 times 5 is 30. I've got the minus 7. Over on the other side, I have an 8x, minus 20 still. Let's see it. Next, I'm going to subtract 8x from both sides, getting all of my the term with my variable term on the left-hand side. 24 minus 8 is, what is that, 16? So I've got 16x, and I've got a minus 37 when I combine those. Over here, that equals negative 20. And I'm going to add 37 to both sides. So that gives me 16 times x, and negative 20 plus 37 would be a positive 17. Now, this is the part where, most students will flip out here, because it's like, Mr. Roberts, I just got the answer 17/16, right? That's not even possible. Now, of course, we know this is not a solution until I check this thing, and that looks a little difficult to check, but I'm actually just going to go ahead and grab my calculator and just kind of crunch the numbers and see. So let's turn this thing on. We're going to go 3/4 times the quantity of, open some parentheses here, 4 times my answer of 17/16, and then minus 5. I'm going to close the parentheses. Oh, I forgot that I didn't pick up the 5. 17/16 minus 5. Close the parentheses, and then I'm going to subtract from that 7/10. So 7 divided by 10. And when I do that on the left-hand side, I get, that's not great, I get negative 1.2625. It terminates. Looks like it's a fraction. Let me display that as a fraction if I can. I get negative 10180. Negative 101 over 80. Well, that's the left-hand side. Let's try it on the right-hand side. Clear. So I'm going to go 4/5 times 17/16 17/16. And I'm going to then subtract from that the number 2. When I do that, I get something different. 4/5 times 17/16 minus 2 is clearly not the same. So that's a bad day. That, to me, is not good. I could double check my left-hand side entry again, but I think I did that correctly. Let's see, 1.15. Let me check the left-hand side entry again before we try to find our mistake. So let's see, 3/5. Actually, I might have entered 3/4, I forget. 3/5 times the quantity of, open parentheses, 4 times 17 divided by 16. That's 17/16 minus 5, close parentheses, minus 7 divided by 10. And enter. Oh! So I made a mistake entering the expression the first time on the left-hand side. Now, if I would have gotten, so the left and the right-hand side are both negative 1.5. If I display that as a it's 1500s, it's negative 23/20. If I would have gotten different values on the left-hand and the right-hand side again the second time after I checked it, the next thing I would have done was I would have gone through every single step trying to see if I could detect a place where I made a mistake. But at this point, I'm really quite convinced that I have indeed the solution here. So let's move on to our next question. Put this calculator away. Next question we have, is an inequality. It says 12 minus 4x over 4 must be greater than 9. So I guess we'll solve this inequality and maybe graph it on a number line. So if I look at this, first thing I'm going to do is multiply both sides by 4, positive 4. So this becomes 12 minus 4x is going to be greater than or equal to 4 times 9 is 36. Next, I'm going to subtract 12 from both sides of this inequality. So that gives me negative 4x is greater than or equal to 6 minus 2 is 4, and 3 minus 1 is 2, 24. Next, I'm going to divide both sides of this by negative 4. And it doesn't take a lot of convincing. Most of you immediately realize that if you multiply both sides of an inequality by a negative value, the direction of the inequality changes. So I'm going to get x equals, or x is less than or equal to 24 divided by negative 4. If I divide 24 by 2, I get 12. Half of that is 6. So this looks like x's are those things that are less than or equal to negative 6. Now, if I plug negative 6 into this, that would be like a boundary condition, and I could think about pushing it to the left or right. I want to check this answer just to make sure. So I'm going to, my numerator, I'm going to look at 12 minus 4 times the opposite of 6. Notice how I use this button for negative. So the opposite of 6. And then I'll press enter here, and then I'm going to divide that by 4. And you can see I do get this boundary condition 9, right? And then it says if I pick something less than 6, or less than negative 6, it should be true also. So I'm going to go with negative 10, and just verify that I do get something larger on the left-hand side when I pick negative 10. So, for example, 12 minus 10, I'm sorry, no, I got that wrong. 12 minus 4 times negative 10. 12 minus 4 times negative 10, enter, and divide that by 4, and I get 13. And 13 is clearly greater than or equal to 9. That's nice. Let's clear this. Put the calculator away. Next question. Let's see. I remember the directions for this. The directions say to identify both the x-intercept and the y-intercept, and then to graph the function. So, I get my x-intercept. That's the first one listed here. I get my x-intercept when y equals 0. So if I was to look at this, I could just set y equal to 0 and look at the equation 8 plus 2x. If I subtract 8 from both sides, I get negative 8 equals 2x, and x has to equal negative 4. So my x-intercept is at negative 4. And I'll go ahead and do that. 1, 2, 3, 4. This is the place right here where I'm crossing the x-axis. My y-intercept I get, of course, by setting x equal to 0. And when I set x equal to 0 here, I clearly get that this has to be 8. So I'm just going to go up to 1, 2, 3, 4, 5, 6, 7, 8. Place a dot there. And it is a slope-intercept form of an equation. My intercept is at positive 8, and I've got a slope of 2. So, and if I go, down 2, back 1, that's positive also. Or from here I can go up 2 over 1, up 2 over 1. I don't think I've got anything that looks like a straight line tool here. I don't think I could draw a very convincing straight line, but, ooh, that's awful. I need to get some kind of a ruler for this. Next question. So I'm kind of interpreting this. I believe the instructions say write the equation of a line that is, and probably graph too. Write the equation line and graph the line that is perpendicular to the equation 10 plus 2y equals 3x, and it goes through the point 2, 3. Well, I know if two lines are perpendicular, let's see, as long as one's not vertical and the other's horizontal, but whenever two lines are perpendicular, their slopes are opposite reciprocals of each other, or their slopes have a product of -1. So if I'm looking at this, I guess I first of all want to find what the slope of this given equation is, right? So I'm going to transform this into slope-intercept form by subtracting 10 from both sides. That gives me that 2y equals 3x minus 10. And I can divide both sides by 2. So that would give me y equals, that's 3/2 x minus 5. So the slope of this line is 3/2. So the slope of my line, the line I'm trying to find, I'll write it up here, the slope of the line I'm trying to find must equal -2/3. Because those are opposite reciprocals of each other. The other thing that I'm given that is that it goes through this point 2, 3. So I'm going to go ahead and plug this into, I guess, point slope form. So I have y minus the particular y that I know, 3, right, equals the slope, which is -2/3 times, open parentheses, x minus the x value that I know. It doesn't say to write the equation in point slope form, but it does say write it in the form y equals. So I am going to distribute and add 3 to both sides. So let's distribute this first. So if I distribute that, that's -2/3, -2/3 x, and then that's going to be +4/3, and that's y minus 3 equals that. So the next thing I'm going to do is I'm going to add 3 to both sides, but I think I'm going to add 3 in the form of 9/3, so I can combine these terms here. So, boy, I'm running all out of room here. I'm going to write this as, I guess I'll write it over here. This is not good to jump from one place to another. This is where mistakes are typically made, so I'm trying to be super careful. Y equals negative 2/3 x. I've got plus 4/3, and I'm going to add to that 9/3, which is 3. So I'm adding 3 to both sides, so plus 9/3. And if I simplify that, I get that y equals negative 2/3 x plus 9 plus 4 is 13 plus 13 thirds. Yuck! What a terrible y-intercept. Let me do this. I'm gonna plot this point by going over 2 up 3. Okay, and then I'm gonna do this slope of down 2 over 1, 2, 3. There we go. So I can go down 2 over 1, 2, 3. So I can go up 2 and then back 3 also. Now, if I was to cross this axis, right, it's not crossing at it's not an obvious lattice point where it's crossing, and I've kind of drawn it so it looks like it's closer to than it is. 19 divided by 3 is it's a 4 and 1/3. 1, 2, 3, 4 1/3. Yeah, I have a feeling that if I probably drew this with the straight edge, I'd be close to 4 and 1/3. Pretty happy with that answer. I hope Mr. Roberts says I got that right. Next question. Graph the inequality. Y's are those things that are greater than 1/3 x minus 2. Are you kidding me? This is easy. Y-intercept is at negative 2, and my slope is 1/3, so I'm going to go up 1 over 3, up 1 over 3, up 1 over 3, and I can also go down 1, back 3. I get the idea. Now, this boundary line, I went the wrong side. I had to go over 3. I can't erase that one. I'm trying to erase. Oh well. Forget this point, that's a mistake. It's down to back 3. This is where it's supposed to go. Anyways, what in the world? That looks awful. Let's see. No, it's down 1. Oh, jeez, but that's a mistake too. It's down 1, back 3. There we go. This is the right spot. I could tell they weren't collinear, but now I'm going to go ahead and just draw the boundary line here, which is a dashed line, because this is strictly y's are those things that are greater than this. So in other words, this boundary line is not included. I'm on a computer, so that's why I'm not using a straight edge, but you should try to use a straight edge when you draw these things. And again, it's y's are those things that are greater than that, so I gotta pick a nice little orange color here, and I'll just say y's are those things that are greater than that. So we're shading everything above this boundary line. By the way, one of the points I like to test, 0, 0 is in that zone. Since 0, 0 is there, if I plug that in, it definitely should make this true. And when I do, I get 0 is greater than 0 times 1/3 is 0, so minus 2. 0 is greater than negative 2, which is totally true also. Next question. Solve this, it's an absolute value inequality. The things that we've been looking at is, a lot of kind of mechanical steps, and I hope that I provided you with some justifications for why we're doing the things we do. Of course, if you have the absolute value, saying that 5x plus 10 must be within 20, and this is less than 20. So if I want to drop an absolute value symbol here with less than or equal to, it's going to be we're going to create two separate inequalities that are joined by A and D. One of the sides of this is 5x plus 10 is less than or equal to 20. And on the other side of that, we end up with 5x plus 10. Now remember what we're doing here. We're essentially multiplying both sides of this inequality by -1 um, to get rid of the plus or minus for the absolute value part. So I multiply that side by -1, and there's no -1 I have to factor in. I'm multiplying by -1, so I flip the direction of my inequality, and this becomes -20. Um, so again, if it's less than or equal to, if your absolute value, and there's so many little conditional statements here, it's ridiculous. But if your absolute value is set up on the left-hand side, right, and you have less than or equal to, or less than, you're going to be joining up with and. If it's greater than, it's going to be two separate inequalities joined by or, and in both cases we do this thing. So let's keep going and see if we get things that make sense as far as solutions go. So on this particular side, for this inequality here, I'm going to subtract 10 from both sides. So I get that 5x is less than or equal to 10. Therefore, x is less than or equal to 2. And on the other side, I get that 5x is greater than or equal to -30. I'm subtracting 10 from both sides. And therefore, x must be greater than or equal to -6. So if I look at this on a number line, just to kind of see if things are cool like that, right? Here's the number 0, and I've got 1, 2. Look at the spacing on that. That's awful. And I've erased my big line too. That's awful. So I try and space that a little bit better. 1, 2, 2. Really? That's crazy. I can't. Okay, and back here I've got the -6. 1, 2, 3, 4, 5, and -6. On this side it says x's are those things that are less than or equal to 2. Okay. Less than or equal to 2. And I'm going this direction. And the other side says x's are those things that are greater than or equal to -6. So greater than or equal to this value. And of course, when I join things with and, in order for this statement to be true, right, both of these conditions have to be met. So x must be both greater than or equal to -6, and it must be less than or equal to 2. So what we're identifying here is that there's just this one region in between, the go region, right? And x's are all those values that are inclusive of the endpoints. Like the way this is set up, those are the values of x that will satisfy this inequality. And, just by a quick inspection, 0 should work. If I put 0 in there, I get the absolute value of 10. Therefore, 10 is less than 20, which is great. If I put a 5 in, -5, let's see, -5 times 5 is -25. -25 plus 10 is -15. And the absolute value of -15 is 15. 15 is less than 20. So that works quite nicely. Well, that is actually it, I believe. Let me double check. Yeah, that's it. So just, kind of a light look at some of the things that are going to be on the test. In terms of equations, I do want to point out that we definitely had situations where solutions look like all real numbers, right? And remember what those kind of conditions look like. It's when we got an identity, when both the left-hand side and the right-hand side of an equation were transformed and they became the same thing. So be on the lookout for that. If we see an identity, remember all real values work. The other thing that you get is sometimes is a contradiction. So if you're solving an equation, you get something like, whoops, not that. 3 is equal to 5, for example. As soon as you see that, you know that the solution is the empty set, because it's never the case that 3 is the same thing as 5. So be aware of that. That's a possibility when you're solving equations, that you can get all real values work, or there could be no solution. What else happened? Oh, when we had our little mini quiz on Wednesday, where we looked at transformations of linear functions. That will be on the test. And I did post a separate video where I at least went over the questions that were on that little mini quiz on Wednesday. So you might want to take a look at that too. But definitely, I will give you a linear function, and I will ask you to, for example, translate it 5 units to the right, and write the new function g of x given f of x. That's 5 units to the right of f of x, or 5 units above or below, or as a reflection across the x-axis, reflection across the y-axis, or is subjected to either a horizontal or vertical stretch. So definitely review those things. Make sure you've got them dialed in. One of the things that's not on this test is scatter plots and lines of best fit for linear data. We're going to tackle that on Monday. So have a restful time, and I look forward to seeing your smiling faces on Friday when we take our test.